Essay 25, The Fallacy of Indeterminacy in Quantum Mechanics. Indeterminacy means that something is absolutely unknowable. This strange idea was introduced in 1927 independently by Bohr and Heisenberg. Not only has it caused great confusion in the subject of natural philosophy, physics, but also in the minds of the general public unversed in the mathematics of quantum operator theory. The operators of quantum mechanics or wave mechanics were introduced by Schrödinger in the 20s, guided by the Hamilton principle of least action and the Fermat principle of least time in optics. Schrödinger's intent was to derive a wave equation for the electron following upon de Broglie's postulate P equals h bar kappa, that all particle momenta are proportional to wave number through the reduced Planck constant. The Schrödinger operators for energy E and momentum P can be used to transform classical equations into wave equations or first-order differential equations. Einstein had proposed earlier that E equals h bar omega, meaning that energy is proportional to angular frequency in radians per second through the same reduced Planck constant h bar. Einstein had also deduced the relativistic expression for energy E. Heisenberg used the P operator of Schrödinger in a commutator so that the commutator of x and p acting on the wave function psi is equal to IH bar psi. Here x is position. This is a trivial reformulation of the Schrödinger operator, and one which does not give as much information as the Schrödinger equation. In the same year, 1927, Bohr arrived at the formula delta x delta p equals a half, simply by making the Fourier transform of a Gaussian distribution. There is nothing new or profound in either of these simple exercises. Schrödinger, de Broglie, and Einstein saw it in this way from the outset. However, Pauli, Bohr, and Heisenberg attempted at the Solvay Conference of 1927 to elevate their exercises into a principle of philosophy called indeterminacy. Usually, this is known misleadingly as the Heisenberg Uncertainty Principle, which saturates the media like the propaganda it is. My colleague and co-author, Professor Jean-Pierre Vigier, mentioned to me at Vigier 1 in Toronto in 1995 that de Broglie was shouted down at that Solvay conference. He did not mention by whom, but my guess is that it was either Pauli or Heisenberg, both notorious for insulting their colleagues or attempting to do so instead of arguing reasonably. I do not know why de Broglie did not shout back with the help of Schrödinger and Einstein and others. So in note 175.3 on the blog of AIS.us, I decided to show once and for all that indeterminacy is a fallacy. This was done by considering the simplest case of quantum mechanics, energy and momentum for a particle wave moving in the x-axis. I worked out the expectation values of x, the square of x of p and the square of p, using the basic formulae of quantum mechanics, found in any textbook such as that of Atkins' Molecular Quantum Mechanics. The first disaster I came across was the normalization is infinite, not unity. This unpleasant fact of mathematics is brushed under the carpet in quantum mechanics by an artifice, restricting the length of the x-axis. If this artifice is not used, the result is disaster for Bohr and Heisenberg, as shown clearly in note 1753. The product of delta x and delta p, as defined by them, is mathematically indeterminate. Delta p is 0 and delta x is mathematically indeterminate. being infinity divided by infinity. The product is not half as claimed by Bohr. If the artifice of restricting length is used, the product is zero. To any rational person, this means that Bohr and Heisenberg are incorrect. The usual interpretation of the so-called Heisenberg Uncertainty Principle is delta x delta p greater than or equal to unity. Even the simplest considerations, such as those in Note 1753, show that this is incorrect. Professor Jose Croce, in his book Towards a Nonlinear Quantum Physics, published in my World Scientific series in 2003, has given copious and definitive experimental evidence refuting the Heisenberg Uncertainty Principle to orders of magnitude. In Baconian philosophy, experimental data are used to test a hypothesis. If something is indeterminate, it cannot be measured because it is absolutely unknowable mathematically. So Heisenberg-Bohr is not part of physics at all, and the standard propaganda on this so-called principle is just that, propaganda of the worst kind. I doubt whether my predecessor on the civil list, Sir William Rowan Hamilton, would have given Heisenberg or Bohr a minute of his time. Einstein, Schrödinger and de Broglie rejected them outright while maintaining a polite silence amid the shouting at Solvay in 1927. Schrödinger and Einstein devised paradoxes in quantum mechanics, as is well known. In my opinion, these paradoxes are not as clear as Note 1753, which uses the simplest of mathematics. Any competent physicist should surely be able to reject indeterminacy using paper 175. One counterexample is enough, but the paper gives many counterexamples using higher order commutators. These were checked as usual by co-author Horst Eckert, and since this essay was written, the paper has become a classic, having been read maybe almost 1 million times, without any objection, in fact. In ECE theory, other explanations have been found for the double-slit experiment in which an electron acts as a particle and wave. For example, Eckert and Bruchholz have given a classical explanation of Young interferometry.